Hi everyone, I wanted to record a quick video this week explaining some of the very basics of probability. This week is about probability, and I promise the math here really isn't difficult. The math is very elementary, but understanding some of the concepts is sometimes kind of foreign. This is math that we haven't always necessarily done before. So while we're really dealing with just addition, subtraction, multiplication, and division, some of the rules and notation and such of probability is sometimes difficult to get used to. So I wanted to take a few minutes to explain some of the details. So I'm going to jump to our whiteboard, and I want to give you some information about probabilities and sample spaces. We talk about sample space as the possibility of all things that can happen. We draw a sample size usually with a box like this, where we consider all of the things that can possibly happen. For instance, within this sample space, we could have event A occur, or within this sample space, we could have event B occur. And the entire sample space, all of the probabilities have to add up every time to 1. All probabilities always have to add up to 1. So let's assume we're flipping a coin. I'll draw the sample space for the probability of flipping a standard coin, and there's 2 possible outcomes that could happen. The tail could wind on heads, or the coin could land on tails. So for each one of these, there's a 50% probability that a fair coin will land on either one. And we know that all of these have to add up to 1. And in probability notation, we list this as 0.5 and 0.5. And this works because our 0.5 for heads plus our 0.5 for tails equals 1. So our whole sample space here for probabilities always has to add to 1. That's one of our basic rules. So in this sample space on the left that I've drawn, A and B are considered mutually exclusive events. They're considered mutually exclusive because they cannot occur at the same time. Notice anywhere in our sample size here, A and B circles don't overlap. So all of this has to add up to 1. So our probability for A might be, for instance, 0.2, and our probability for B might be 0.2. So that leaves 0.2 plus something has to equal 1. And we know that 0.2 plus 0.2 is 0.4. So that leaves 0.6%, 0.6 probability that neither A nor B happen. So within this space, instead of 2 possible events like heads and tails, there's 3 possible outcomes in this sample space. Either A can happen, either B can happen, or neither A and B can happen. The probability of A is 0.2, or we would call it 20%. The probability of B is 2, or we would call it 20%. And the probability that neither happens is 0.6 or 60%. All of those add up to 1. So that rule of probability holds every single time. In this drawing, A and B are considered mutually exclusive. They're mutually exclusive because they cannot occur at the same time. Another one we hear is disjoint. We say that A and B are disjoint. So another term that we want to use in statistics is the complement. The complement is the probability that an event will not occur. The complement is sort of an opposite. So up here, the complement of heads is tails, and the complement of tails is heads. We know that one of them has to not occur. and we can calculate the probability of an event not occurring in our sample space, because we know that our whole sample space has to add up to 1. So if we have a probability in here that might occur, like event A, which we will say has a 0.3 probability, the complement of that would be of A not occurring. And we write that as A prime with a little mark here. So if we know the probability of A occurring is 0.3, and all of these have to add up to something to be 1, we can figure that the probability of A not occurring is 0.7, because we know these have to add up to 1. A is the probability that it will happen, with A prime is the complement that it will not happen, and we mark that, and we know that all of these have to add up to 1, so we know this has to be 0.7. So in this drawing, the probability that A will occur is 0.3. The probability that A will not occur is 0.7. Now I'll take a break there and point out that, as you see here, remember, the math is not terribly difficult. All we're doing is adding, subtracting, multiplying, dividing, basic stuff. But it's hard sometimes to think in terms of events. It's hard to think in terms of sample sizes. And sometimes we're taught this using coin flips or a bag with marbles in it and such. And this week we're going to try to give some examples that put these into more real-world terms that tell us what we're doing. So given that, let's look at some of the rules and some of the operations we do with probabilities. And I want to start by showing you some of the notation we use. The notation sometimes is a little bit different. So here we've talked about the probabilities of A and B. Another thing we can do is, what is the probability sometimes that both occur? So I could draw a sample space like this, and we could draw event A that could happen, and we could draw event B like this. So in this sample space, which must still all add up to 1, we have several different possibilities. Here, A and B are not mutually exclusive. They're not disjoint, because several different things can happen. There's a certain part of our sample space where it's possible we know that A occurs. There's a certain part of our sample space we can see here where B occurs. There's part of our sample space where neither A nor B occurs. So that's a probability that we have to account for. And there's also a possibility in here where both A and B occur. So these are not mutually exclusive. What we call this space in here where A and B both occur is the intersection of A and B. That's the intersection of A and B. And the probability that that occurs, or the way we define the intersection, is A and then sort of this upside down U, B. And we put parentheses around that, and we use the probability as capital P. So we would denote this space here as the probability of A, this upside down U, and B. So if we're looking up here, the probability of A and the intersection of B, where they're mutually exclusive, is 0. There's no overlap here, so that probability is 0. The way we've drawn this sample space, that's non-zero. There is some overlap here, so there is a probability that can occur. That is the intersection of those two events. We could also look at what is the probability that either A or B occur. We want to know the probability that either or both of these occur. So we might want to see every possibility in here. We draw that a little bit differently, and we call it the union of A and B. And it's drawn as the probability of A, and here we turn that U over, and it's a big U shape, the probability of A union of B. So that would be the possibility that either A or B happen, or both of them. That excludes all of this part of the sample space out here. So we could assign some values to the probability of A and probability of B and calculate those two events. There's one more bit of vocabulary I want to give you before we go and look at some of the operations we can do on this, and that is dependent versus independent. Two independent events, A and B, are completely separate from each other and have no bearing on each other. If there's two sports contests during the day, the outcome of the second contest doesn't typically depend on the outcome of the first. Whichever team wins the first game doesn't play in the second. They're two completely different contests. They're independent of each other. If I flip two different coins, one in my left hand and one in my right, what the coin in my left hand comes up as has no bearing on the coin in my right. Those are independent events. They have nothing to do with each other, and they don't influence each other. If the events do have something to do with each other and influence each other, they're called dependent events. So that's two more pieces of vocabulary I wanted to give us: independent events and dependent events. So now let's look at some of the math that we do for the rules of probability. We've already looked at the rule of subtraction. The rule of subtraction tells us that the probability of A happening, so capital P and the probability of A, equals 1 minus the probability of A prime. So this just tells us that our whole sample size has to add up to 1, and the probability of A is 1 minus the probability, which we looked at here. That's the rule of subtraction in statistics. The next one we look at is the rule of multiplication. The rule of multiplication says that the probability that A and B events both occur, so we're looking at a system like this, like in this drawing here, where A and B both occur, is equal to the probability of A times the probability of B, given that A has occurred. So we write our rule of multiplication like this. Capital P for probability, A, and we're talking about the intersection of those two. So if we wanted to find the intersection of those two, it's the probability that A occurs times the probability that B occurs, and then we write a vertical line given that A has occurred. So this is our rule of multiplication. This is how we find this union of the two, the intersection of the two. I'm sorry, that's the intersection of the two. The next rule we deal with in probability is the rule of addition. The rule of addition says that the probability of A and B occurring, so now we're dealing with this union down here, the union of A and B equals the probability of A occurring plus the probability of event B occurring minus the probability that we just calculated up here, probability of A and B occurring. So to find this union, it's the probability of A plus the probability of B minus the probability of both of them. So if you look at this graphically, if we call this A here, that A looks a little bit bigger, so we'll call it 0.3, and we'll call the B 0.2. We have to add these both up and then subtract out the space in the middle. Otherwise, we would kind of be double counting this space in the middle. And we just want to see this complete union that I've drawn in green. So that's why we use this rule of addition here. So those are some basics on probability and how we do some of the notation. There's a lot more in the materials for this week, but I wanted to talk you through how we sort of draw these sample sizes and look at these events. Another thing I want to point out is that you should never, ever, ever feel bad about physically drawing these drawings. I do it all the time. I sit down and draw out the sample space and look at the events and the probabilities all the time. If you draw them out and write them down, you're much more likely to arrive at correct answers for these things. Don't feel bad sitting down, actually drawing the boxes and the circles, figuring out A and B and giving these names and writing them down. It's much easier to understand. If you have any questions, of course, let me know, and thank you for watching.